So today we will be solving a new lit code problem called merge case sorted list. So let's look at the problem description. It says you are given an array of key linked list. Each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. So here we have number of, let's say here for key number of sorted list, and the k sorted list we have to merge all those three and output a new sorted list. So looking at the problem, the first approach that comes into my mind is using kind of like brute force, where you will compare the two linked list, sort it, and then output and save those value into a linked list. Similarly, we will repeat that process until it hits the end of the list, and we'll have the final sorted list. But the solution to this problem is not a optimized one, as the time complexity would be uh, I think n k square, or let's say n square, where since we'll be comparing the two lists, that's the n square, and we'll be doing it for each and every list. So there are, suppose for example, there are n number of lists for here, let's say k number of list. So the time complexity would be kn square, and which is not an optimal solution. So we'll look over the optimal solution, and where we'll be using the concept of minimum heap, where we'll be using priority queue. What the priority queue does is that it sort the list for a certain size. As okay, looks like I'm talking a lot. So let me take an example. So if, for example, there is 2, similarly there are 3, or let's say now we'll have 4. So what the priority queue does is it inputs this node into the priority queue, this node and this node. So it will sort the first 3 node of each and every list. So for this one, it would be like 0 node, 1 node, and 2 node. Since we'll be using the minimum heap, the smallest value will be at the head of the queue. So 0 will be at the head of the queue, then 1 will be added, then 2 will be added. So once this get added, then what we do is we will add the smallest or head value to the result. And once the smallest or head value is added to the result, now we do not care about that node, so we'll move on to the next node. So for example, here, this is 0. So this node will pull the value out of it, and we are no longer considering this node, so we'll move on to the next node. So here, so the next phase will have 1, 1, 2. So the 1 will exist as earlier, 2 will be existing, 0 is already added to this final list, so it will move on to the next node, and that would be 1. So this is how it goes. And the time complexity for this approach would be uh, n log k. K log k. Since we have k list, will be performing uh, k log k. That's the time complexity for any priority queue, and that's the size of the list. And n is the depth of each linked list. So it would be kind of like the maximum size of the linked list. So let's go with the solution now. So now here I have priority queue, and the priority queue would be a list node. So I'll just give a simple MPQ priority queue. So now A comma B. So here are the two. That's how priority queue is defined. Like we'll take the first two values A and B. So how it is supposed to be sorted. That would be A minus B dot val. That is the since that is the lowest value would be at the first or the head, and the large value will be the later. So now let's use a for loop for the list dot, since this is an array dot length I plus plus. Now we'll check if any of the list is not equals to null. If it's equals to null, then we will just ignore that value. If it's not, then we are going to add that value into the priority queue. So now we have, as for example, if we have this 3 list node, then 0, 1, 2 will be added over here. So now list node final list equals to new list node. So this node is used to keep track of the head of the sorted list we'll be creating at the last. List node template final list. Template is used to save the sorted list value throughout the process. So now we'll be using a while loop. If not, pq dot pq dot is empty. If parity is not empty, then we'll keep on continuing this operation. So now template dot next we'll add that value. As I said earlier, 0th value will be added to the template, and that's the sorted list. So here it will be p parity dot poll. We'll pull the header of the sorted list. So now template dot next. So we'll move the template to the next node. Okay. Now we'll check if tmp template dot next is not equals to null. If it's not equals to null, then we'll add pk dot add tmp template dot next. So now we'll return final list dot next. So now here why I'm doing this is that, okay, here I have 0, 1, 2 added into the parity queue. Now for the next node, what I'm going to do is I'll check if the next node of 0 is null or not. If it's null, then we are going to ignore this list, because that list will be already be merged into our final list, or the temporary list here, what we say. If not, then we still have one or a couple of node left. So we'll move on to the next node and we'll add that to the priority queue. So now let's try running it. Okay, it looks like it passed. Now let's try submitting it to see if it passes all the test case. Okay, here we go. So it passed all the test case. So we're good. So if you like this video, please like and subscribe to it. Thank you.